All right, in today's video, we're going to be talking about the AutoCAD MEP toolset. They provide a toolset on top of AutoCAD architecture for drawing pipe, duct, conduit, cable tray, and they refer to these objects as AEC objects. AEC standing for Architectural Engineering Construction. That is the general industry the software is meant for. So this is a tool set built onto the AutoCAD MEP vertical, and these tools are MEP specific only. If you compare these tools to Plant 3D, they are different base entities. The way they're constructed are different. So this video is only going to apply to AutoCAD MEP. Now we've already gone over the architectural tool set, and that's here. You will find also up here an electrical ribbon, HVAC ribbon, piping, and plumbing ribbon. If you want to draw pipe, conduit, all those things, these are the tool sets here to use. So you can just come here to electrical, conduits, and we'll talk about how to do this more, but it's really as simple as drawing just like this. And you can take a look at this in a 3D view now. And you can see there is an elevation. There is a 3D component to this, and we're in 2D wireframe right now. We could switch over to realistic and look even better. So we're going to be going over how to draw this stuff today. We're going to start off by pointing out that we've dropped a pump in here as well as a heat exchanger. Whenever you're dealing with the MEP tool sets, you always want to have properties penned. It's just a best practice. So for example, if you need to insert equipment and you want to insert out of the box equipment, so smart equipment, you can just come here and you can pump. You'll get this dialog box. It'll look something like this. You can change, you can select different pumps in here. You can select different sizes. You're going to want to specify the elevation that they're going to come in at. And for example, we can select this one, select a different size, and then this one might be having trouble inserting. I was having some trouble earlier. Let's see if this one does. Yeah, and then you can just place on plan just like this. So that's how you can insert equipment. And then notice that we have these tool grip, these tool tips, this exclamation coming off of here. So if you click on this, the tool tip, the exclamation is telling you there's nothing connected to it right now. And it's been identified as a connector. So we can just grab this plus icon here, and we can begin to draw piping. This equipment has been configured to have a piping connector on it. If this was HVAC equipment, it would be configured for an HVAC, a duct connector. When you begin to draw this stuff, when you are inserting pipe, for example, off of this flange, it knows that it needs to insert a flange. So it's asking you here with this dialog box, what kind of flange do you want to insert? So you could ductile iron, or maybe come down here to like stainless steel or something. So we can just hit OK on that, and we can just kind of begin routing. You'll get the hang of this the more you use it. We're gonna undo this, and let's begin an exercise of connecting this pump to this heat exchanger. To do that, we have a few options. We can come up here to piping, just pipe, and it'll launch that command. Notice the name of, if you need to do it in command prompt, that's the name. You'll want to pay attention to these options down here. So for example, elevation and size are going to be the ones that you're using most often. So elevation, I can just set this to 10 feet. And let's say that I'm not starting with this. This is now at 10 feet. Now, if I need to do a drop down, I can come down back here to elevation, or use the tooltip E. So I'm going to do E space there. It's asking me what elevation. So now we're going to do 5 feet. You see that it inserted a conduit drop there, or piping drop. Right click to finish. What does that look like in 3D? Looks like that. Perfect. Okay, so using those same workflows, you can do everything from, you can change the size, so from 6-inch to 3-inch, and all of these others. And I'll let you learn about these on your own. You can look at the AutoCAD help, routing preferences, and justification and slope. Those are things that you're going to probably want to know about. So for this demonstration today, let's just go ahead and select our pump and connect it up to this heat exchanger. So there's a connector already established on this pump because it's out of the box and it comes with a connector already established. So we can just hit that plus icon, and we're going to go over 2 feet. So I can just do that. I just typed in 2 feet. It's thinking, what flange do you want? That one's fine. I'm then going to enter the elevation. So I just typed in E space there, and I'm going to bring it up to 10 feet. And we're just going to come over here and do something like this. And it can do some auto routing. So notice this grip that I have here. This grip is not standard AutoCAD grips. I actually have my AutoCAD grips turned off, and I only have the MEP grips turned on. So object snapping F3, it's off. So all of these are not being acknowledged right now. However, there are MEP grips down here, and these are on. Notice that you can toggle these with Shift F3, whereas all these are toggled by just F3. So I've turned off F3, so none of these are being acknowledged. We're only seeing MEP grips right now. It does have the capability to do auto routing, so I get that grip, I can click there. Notice in the toolbar down here, it's asking me to preview the solutions. So let's zoom out here, show me the next one, next. It's showing you all of your different options to get this done. So I'm going to go back to 1, and I'm going to accept that solution, and you're done. And now you can continue routing other stuff if you'd like. So we're going to back this up just a little bit, and instead of using the auto routing solutions, we will do this manually here. So again, I'll do elevation up to 10 feet and inserted a elbow there. I did notice today, as preparing for this, that object snap tracking does not appear to work for MEP snaps, which was, I did not expect that. And if you do point filters, this is, I don't know if I've talked about this, this is shift right click, you get to this point filters menu. So then you could try to acquire this y-axis point here and go about it that way. And then now I can do this, and again, you're going to get these solutions. So I'm just going to go ahead and accept that solution. I bet you that solution was just the variance in it would have been where this elbow down, where that would have been if the elbow down was down here, or if it was done on this connection here. So that second demonstration that we did just there, just remember you do have this concept of point filter tracking. So if you need to acquire a Y or X coordinate because for whatever reason object snap tracking is not working, you can go about that. If you need to learn more about object snap tracking, the AutoCAD Help has a ton of information on it. I do recommend that you be an expert with snap tracking. Okay, back to the point of this video. So we've done a nice little system here. Now, when we select this, we do get a contextual ribbon up top here, and these are all tools related to these AEC pipe objects. If you wanted to select everything that this was connected to, you can come over here and select connected branches. And you notice down here, you can actually select all, and that's all of them. So I'm going to right click to finish. I actually want to unselect my equipment because I'm going to change the system. So now we're going to introduce this now. So when you're routing these AEC objects, they can belong to a system. So right now we're in chilled water return. So if you were doing a job and you needed this to instead be on boiler feed water, you can switch to that. Notice my layer just changed as well. So these systems, when you set up a job, you're going to want to set up the systems that your job could use. You're also then going to want to set up what's called layer keys, and we'll learn about that more later. But you can map a layer to a system. That way it's automatically switching the layers of your pipes depending on the system that they are. So to reiterate, no, you do not need to manually set your layers when you're messing with AEC objects because the layer key mapping does that for you. So more on that later. All right, so now we're going to just give a quick demonstration of the other tools. So here's HVAC, here's duct. We're going to launch this commands. We can start by setting our elevation. So I'm going to just put this at 10 feet. You can also change the shape. So shape, rectangular, round. What do you want? So we'll route some here, and then I'm going to actually change my size. So we are, we'll follow our prompts here. So I'm going to change this from 3 inch to 6 inch. And now it's going to ask, how do you want, what kind of fittings do you want to happen here? And it will tell you if there's predefined multi-view parts that can do this, or if it needs to generate a parametric one. That's a fancy way of saying is able to generate fittings for you to make these transitions as needed. Obviously, you should follow engineering best practices and those kind of things. Okay, so and boom, just like that, it's able to actually create these fittings for you. Notice that when I select this and properties, top left, this is duct. This is duct fitting. Okay, so notice that this inserted a annotation object here to label the size. The sizing of this annotation is configured via annotation scale, not dim scale. Duct is set up automatically to come in with these tags. Piping, as you can see, is not. If you want to disable duct from having these tags come in automatically, you can do that, and you would do that via display manager for all styles or style manager for a specific style, and we can go into that more later. Okay, so that's duct. We'll just give you a round robin here of all of them. So this is conduit, pretty simple to do. Again, just like that. Notice again, this is going to be a conduit fitting, whereas this is going to be conduit. Let's do CableTray. And with CableTray, you get a dialog like this first, where you can declare the width, height. You can also declare the system, so you can take a look at this. You can also adjust the justification of this. So we will just click and we'll try to start routing this. I believe if you do Shift, no, maybe it's Tab, no. Okay, there's maybe I'm thinking of Revit. And you can, again, just route this stuff. Now, it has routing preferences set up per size. So for 12 by 3, it knows that this bend radius here needs to have a specific bend radius, which I'm not seeing in here. But out of the box settings, it will use fittings that are industry standard. And actually, if you compare how the stuff is configured, you'll see that it matches almost every manufacturer's CableTray catalogs and in respect to things like that. I think that is mainly what we wanted to show. Plumbing, there are plumbing tools in here too. You are able to have sloping lines, which is important for plumbing. All right, hypothetically, let's say that you drew a parallel set of conduits here, which is this is drawn poorly, but if you needed to delete the entire set of parallel conduits, there is not a tool out of the box to do that. If you are able to do a selection set of it, great. You can just take that, delete that. We have written into our AutoCAD distribution a command that does this recursively using this select connected branches up here. What you need to do to run that command, you just select conduits, the conduits that you can, and then it's AEC all. And we'll see how that works here. And it's able to get your selection there. So if you need to select everything, all connected branches of multiple objects, AEC all is a good command. Some of the biggest benefits of these tools are, one, it does know when to use the correct fittings. Two, you're able to BIM tag these fittings and BIM tag the size of these pipes, so you're able to have BIM information that's stored on this pipe here. So if we're looking at properties, it has this BIM information here, such as it even has routing preferences, which we'll go over later. But if you come down here to extended data, you can add property sets here, and we'll just hit OK on that. And notice it's able to pull in all this BIM data, such as cut length, center of pipe, bottom of pipe, abbreviations for the boiler feed water. So you're able to set all these kind of things up and pull this BIM data. And so let me show you this. We'll come here to piping annotation area here, pipe tag, follow our prompts, select object to tag. I'm going to right click to finish. It's going to insert a pipe tag. It's going to tell you which property sets it's going to use for this. And typically just hit OK. So you get this. Maybe this is not the correct style that you wanted to use. So if you select it in properties here, we can come back up here to design, and we can actually change this from using this out of the box one to maybe using TEI, BOP, and all this. It's looking pretty good. Nice. Now we do actually have these tags set up in a palette. So TE Mechanical, there is a scheduled tags palette, and you can actually just come in here and select these. and it'll insert it just like that. And this time you don't have to manually change it in properties. So we talk about scalability and best practices a lot. You want to be using AEC objects, one, because you can tag them, but two, you can also schedule them. So this scales really well. If you change the size of this pipe for whatever reason from 4-inch to 2-inch, if you were manually tagging this with mtext, you'd have to remember to go back. So it's not scalable. It's not a best practice. Speaking on that vein of leveraging BIM information, metadata information, property information, expanding on that and leveraging that, we're also able to generate schedules. So to do that, for piping, we'll just come up here to piping and the annotation. We'll do this drop down. You can select any of these. Before you insert it, you are able to change the style of the table here. So if you create a custom one, again, you'll just select any of these, and then before you follow your prompts, you can then change the style. And we can just do a select all on all of this piping. It will filter out objects that are not built into that table. And just follow our prompts here. We'll do something like this, and now we get a BIM table. Looks like this drawing did not come from the right template. We do have a template set up that is able to pull properly all of the pipe fitting data and generate bill of materials. And I've got 2 or 3 videos on this subject if you need to learn more. So again, best practices, scalability, those are the kind of things that we want to be thinking in terms of. Even if you're doing a job that's at 30% design, it makes more sense to still draw everything using these AEC objects. I cannot think of a circumstance where it ever makes sense to draw anything in 2D polylines, just because it doesn't scale once you get to schematic design. So even if I didn't know, like let's say that this equipment was not a smart equipment, it's not a multi-view part. Like let's just say that this was a block, this was line work. I would, and I didn't have these connector objects, and I didn't want to worry about elevations or elbow fittings, things like that. That's fine. You can still, rough things in, and just by doing something like this. And the reason why this is going to be nice is, one, if you do add elevations to it, it automatically inserts the pipe drops, things like that. You may be concerned that this is showing 2 line and maybe you want it to show 1 line. There are also settings to make that happen. So if you want your pipe to show in 1 line representation, right now it is in 2 line representation, you would adjust what's referred to in MEP as display configuration. So down here next to your workspace, we're in Thermaltech Plan. This is the default one. You can switch to Thermaltech 1 line. And notice that these now become 1 line representations. It's really nice because the elbows, they're automatically inserted. You don't need to insert from the palette wherever those are at here and do it that way. So again, scalability. This is the way to do things, even if you're at schematic design. You can also adjust single line settings to say sizes over 6 inches. I want you to always display them as 2 line. Sizes below 6 inches, I always want you to display them as 1 line, regardless of what your settings are here. We can go over how to configure those in just a little bit here. If for whatever reason you're finding that you're missing tools that you expected up here, we do have additional dedicated workspaces set up for piping, HVAC, those kind of things. These are out-of-the-box workspaces, so you can switch those over. Again, a workspace declares your ribbons up here and the tools available to you. Okay, so that is an introduction to these tools. I highly recommend you use them. Again, best practices, scalability. When do you know to use AutoCAD MEP toolsets versus Plant 3D toolsets? It really depends on the degree of complexity for your project. Heavy industrial jobs, think refineries, chemical plants, those are going to be probably better suited by Plant 3D than AutoCAD MEP. The only thing that we did not talk about is pipe valves, and that can be done right here. Okay, so now we're going to talk about more of the setup side. So you've started a project, and one of the things that we discussed was you are going to want to set up systems for all the different types of piping systems that you're going to have. Or for example, maybe you're going to have CableTray, and there's going to be medium voltage CableTray, 480 volt CableTray, and then low voltage like communication CableTray. You'll want to set those up Same thing with ductwork, supply air, return air. So to do that, we'll go to manage here, and remember that we have style manager and display manager. MEP is a style-based program. So these two are going to work in conjunction. You can think about display manager as affecting all objects, and then style manager as a child class to display manager, where it allows you to fine-tune things a little bit more. So we're going to come here into display manager, and we're going to come in here to style manager, and style manager is going to allow us to declare different systems. So we can open up piping objects here, pipe system definitions. These are all the ones that are declared already. So you can right click new, and you can create your own. So let's just take a look at boiler feed water, how this is set up. So here under design rules, layer keys, this is how it knows to assign a specific layer to the system. So I believe layer keys are done here in the multi-purpose objects section here. So you can come into layer keys. If you needed to add a layer, we'll click on the MEP one, and a lot of these are predefined. We have a lot of these M1s here and H that we created from our Thermaltech standards. And you could create new layers, and you could assign them to these different systems here. So you're going to want to set up a system for each job that you're on. You are able to define how rise and drop is done. So if you need to, the symbology that we're seeing here, if that's not how you wanted rise and drops to be done on single line graphics, you can adjust that here. Earlier we talked about single line graphics. You can adjust this setting here if you want to display all sizes below a threshold as 1 line, and above that 2 lines. So you can configure this thing by system. And then lastly, display properties. So these display properties, unless there's a style override checked here, these display properties are inherited from display manager. So notice that it's in bold right now. This bold is telling us that we are using a display configuration, display representation that is in 1 line. So if you double click on this, this is the same menu that you will get within display manager. And we're not going to get into this a lot right now. I've got other videos on this. But for example, if we wanted to, let's actually get out of this. But for example, if we wanted to get rid of this center line that we're seeing here, that would be configured via those display manager settings. So I've opened up display manager here, representations by object. We can come down here to pipe, and for 2 line, which is the one that we're in, we could turn off center line just like that. And I must have done something incorrectly there, but that would be how that's done. That should be a pretty good overview for using these. Again, best practices, scalability. We've got a lot of videos on fine-tuning the style manager and display manager. Again, set your systems up at the beginning of a job. Make sure those systems are set up in your DWT, in your drawing template file, in which all project navigator files are based off of. So if you needed to, when you come up here and new sheet, this is pulling from your DWT that is declared for your job. And so again, set up these standards at the beginning of your job in your DWT file. And that should be a good overview. So we'll end it here.